Alright guys, so today we're going to learn how to graph a system of equations. So our warm-up here is to take this linear equation here, and we're going to go ahead and we're going to change it into from standard form to slope-intercept form. So that's easily doable by, we're just going to add 3x to both sides, make our lives easy. And when we do so, we get the equation y is equal to negative 8 plus 3x. So that's easy enough to graph. Okay, we just have to start down here at negative 8, up 3 over 1, up 3 over 1, up 3 over 1, and I think that's enough points, to go ahead and be able to graph that. So switch over to my line tool here, and voila, I have the linear equation that I set out to graph. So now I think we're ready to go and sufficiently warmed up in order to proceed into the lesson. So today's lesson is graphing systems of linear equations. We are learning how to solve a system of equations by graphing. We are learning this because it's important for creating mathematical models and solving them. And you can graph a system of equations to find where the linear equations intersect, and that's how you know you're going to be successful. So what we're starting with here is we're starting with the basic definition of what is a system. So a system of linear equations is when there are two or more linear equations working together. So as you can see here, okay, you can see that we have this blue line here representing y is equal to negative x plus 5, and we have this red line here representing y is equal to 1/2 x plus 2. They are in a system of equations, and so they occur on the same graph. And this point of intersection 2 comma 3, so x coordinate 2, y coordinate 3, is the solution to a system of linear equations for this particular one. That is the coordinate where all of the lines intersect. So if there are more than just two lines, then we have we have one single solution where every single one of them intersects. So that's just something to be aware of. So there are three types of systems. The first is independent. The system has exactly one solution. The majority of the systems that we cover are going to fall into this category. We're going to be solving the majority of our systems to find where they intersect. The next one is dependent. This system has an infinite amount of solutions. So what that means is that the lines in the systems are on top of each other, and because of that, they have infinitely many solutions since they'll always touch each other. And the third kind is called parallel. This system has no solutions, and the lines in the system have the same slope, and because they will never touch each other, this means they cannot have a solution. So if they're parallel, that means that they are no solution. So just a visual representation of that, we have the point of intersection. See, I already drew a little arrow to it. This is what we're going to be hunting for the majority of our problem solving. We will come across some that will never intersect, and those lines you can see, the red line and the blue line here are parallel, so they will never intersect, so they have no solution. And then we will come across some where you end up graphing the same line, maybe perhaps they're in different formats when we first see them, and so those will be infinitely many solutions. So the three ways to solve a system of equations for the coordinate that is the solution is that you can either graph it, use substitution, or you can use elimination. And so today we're going to be focusing on the graphing aspect of that. So to solve a system of equations using graphing, we're going to determine what form both equations are in. If they're in standard form, we're going to have to graph that using the intercepts. Alternatively, you can convert them into slope-intercept form, whatever's going to work better for you. And then if they're already in slope-intercept form, graph it as we've practiced. And then the idea is to locate the point where the two lines intersect. So that is the solution to the system of equations. So here I have my basic system where I have one equation up top. This one right here is in standard form, and then this one's in slope-intercept form. So if I start with the slope-intercept form one, I can easily graph that bottom one. Y is equal to 1/2 x plus 5. So plus 5 is here because that's my y-intercept. And then up 1 over 2 is going to be easy enough for me to graph. I can easily get that pattern down. And then I'll use my line tool because I'm not going to be able to draw a straight line here. I'll use my line tool to set that line. Now for the other one, I first have to make sure that I put it in slope-intercept form. So I'm going to just add 3x to both sides. And when I do so, I get a nice and simple equation. Y is equal to 3x. That's a nice simple equation, easy enough for me to graph. It doesn't have a y-intercept. So it's going to go through 0, 0, and then it's going to go up 3 over 1, up 3 over 1, up 3 over 1. So if I use my line tool again, set my linear equation there, boom, right in the middle there, I easily came across that coordinate which represents the solution to the system. So I can go ahead and say that that coordinate is at 2, x coordinate 2, and it has a height of 6. So 2 comma 6 is the solution to this system of equations. The next one, okay, find the solution to the system of equations by graphing. This one's already in y-intercept form, slope-intercept form, excuse me. So we'll start at plus 4, and then it's negative 1/2 x, so down 1 over 2, repeatedly. Sets up my points like that. So using my line tool, I've got my slope and y-intercept correctly graphed. So here's the line that represents 1/2 x plus 4. The other one, I'm going to go ahead and I'm going to solve it using, or I'm not going to solve it, but I'm going to use my intercepts and try to locate where they are in order to graph it. So if I set x equal to 0, so if I set x equal to 0 for this bottom equation here, that means I get 2y equals 12. So then if I want to divide by 2, that means that y is equal to 6. So I do have a y-intercept of 0, 6. Okay, so that's going to be up here. Easy enough to find. The next thing I'm going to do is I'm going to plug a 0 in for y. So I'm going to let y equal 0. And when I do, it turns into x equals 12. So you know what? That is unfortunately off the graph. But if I just continue here, so here's 10, right? So if I just go 1, 2, and I put my line there, or a dot there just to represent where I am estimating 12 is going to be, and use my line tool. Oop. I accidentally, there we go, use my line tool here. Oh my goodness, I have discovered that these lines are parallel. So since they're parallel, I'm going to go ahead and have to make the assumption that each one of these, or this system, has no solutions. So this is an example of where I see that they're parallel, so there are no solutions. And finally, here I've got two systems, or two two standard form equations, excuse me, and I need to graph them. You know, the top one would be pretty tough actually if I just plugged in the intercepts, like if I did x equals 0, y equals 0. And the problem that I'm going to have is because I have a 0 over here. That's going to create problems when I solve for 0 because I'm going to get an x and a y intercept of 0. So it means it's going to go through the origin, which kind of stinks. So I am going to have to turn this top one into slope-intercept form. So if I do that, if I subtract 2x from both sides, I get negative 3y is equal to negative 2x. So that's me subtracting negative 2. That's me subtracting 2x from both sides. If I wanted to reduce that y divided by -3. Now, a negative over a negative is going to give me a positive. So that's going to be 2/3 x. That one's easy to graph. See, but now I did need to do that in order to calculate the slope because finding the two intercepts is only going to give me 1 point down the middle. So up 2/3, up 2/3, up 2/3. All right, I have enough in order to graph that equation. So there's the line. Now the other one, I can definitely do in that other format where I let x equal 0 and let y equal 0. So if I let x equal 0, for the bottom equation here, that cancels out, so I get 2y equals -8. Easy enough. And then I need to divide by 2. And when I do so, I get y is equal to -4. All right, easy peasy. So I will plot 0, -4 as my first point, and then I'm going to plot my y, or my x-intercept, excuse me. So to do so, I'm going to set y equal to 0. Pardon me, that's a y. And when I do that, I get -4x equals -8. And when I divide by -4, I get x equals 2. Okay, so I can plot that right here. And it's easy enough to kind of tell that from here to here, I went up 4/2, which kind of means I have a slope of 2/1. So I can just kind of guesstimate where some of these other points are going to be. But if I go ahead and fill in my equation here, draw the line, I get that they cross here. And the solution then would be 2. Oop, that's a bad 2. I'm going to try again. 2, 3. So I have found the solution to the system of equations by graphing. All right, guys, that's it.